Okay, now welcome to this video on the trapezium rule. So quick starter. So pause the video, have a go, and then come back when you're ready. Okay, welcome back. So this one is about a trapezium. So I'll draw the trapezium. So it's right angled. It's got parallel sides 8 centimeters and 6 centimeters. And it's got vertical height 5 centimeters and the slant height is 7 centimeters. Find the area. Remember, the area of a trapezium, the formula's in the front of the exam paper, but you should still remember it. It's 1/2 bracket A plus B times H. Remember where A is one of the parallel sides, B is the second parallel side, and H is the vertical height. This slant height is not helpful for the area. So put your numbers in. 1/2 times 6 plus 8 times 5. Well, the bracket's worth 14. Half of 14 is 7. 7 times 5 is 35 centimeter squares. Okay, this formula here, very, very important. Okay, don't forget it. Right then, the trapezium rule. You might see in future videos that if you can work out the area under a curve, it's actually got a really important meaning. It's highly significant. So it's worth being able to work out the area under a curve. All right. But just think about how hard it would be to work out the area under a curve by eye, for example. Like if you look at this graph here, imagine how hard it would be to work out the area, because like it's a curve. I see it's all curves here. There's no straight lines. All right, there's no rectangles you could use. So there must be a way to do it though, okay? And there is, by using the trapezium rule. So there's an example here, okay? You may want to copy this down because it's got some quite technical terminology in there. And then I'll come back when you're ready, okay? Okay, welcome back. So the first word that jumps out here, all right, is the word ordinates. Ordinates are just points on the x-axis, all right? Coordinates are x and y pairs. Ordinates are just points on the x-axis. So x equals 1, 2, and so on to 5. So I'll go to my graph. Look, here's the graph. And I'm going to mark those points. Okay. 1, 2, 3, 4, 5. I've marked the ordinates. It wants the area bounded or trapped by the curve and the x-axis between those values. Okay, so here's the x-axis. Oh, it should urge me. Here's the x-axis, this horizontal line. So if I read up for my first ordinate with a dashed line, okay, the area we've been asked to find is, well, I don't even want to cover it all in very well. All this yellow bit, okay, under the curve is what I want to find. Okay, that's my goal, to find this area. And you can do it by using the trapezium rule, because if you repeat this process now, okay, with all the ordinates, I don't want to put crosses where the graph meets the curve as well. But so where the line meets the curve. So you keep going up from here to here. There's this one. This one, if you read up, hard me to do without a ruler, okay? Here, look. And then this one's already done. If you join these together, I'll try and do it, but I may mess up here. Insert shapes. There we go. If you join these points together now, so there's one. Let me make it very thick, about 6 point. I'll make it blue. Okay. Then go again. Oh, try again. Sorry, shape outline. Blue, dark blue even. Weight, 6 point. All right. Then repeat the process. See, join this one here to that one there. I'll just do it freehand. You see what I'm trying to do now. Okay, do it freehand. Okay. So you join this one to this one with a straight line as best you can. That's all. Let me try again. Here we go. Okay. This one to this one, and this one's going to be a nightmare. I'll have to try and do a line here for this one. I'll have to. Shapes line. Hopefully this will work. Yeah, it does. See, join those up. Make it 6 points. And hopefully you see what I've done here. Okay, I've actually made some trapeziums. Okay, 5 of them. Okay, see this trapezium 1, trapezium 2, trapezium 3. Sorry, I made 4 trapeziums. 1, 2, 3, 4. If you can work out the area of these trapeziums, you can add them all up, and that will tell you the area under the curve roughly. It won't be bang on because these bits here are not going to get counted, but it's going to be pretty close. Okay, so I've got a blank slide now. All right, I'm going to first of all do a sketch of trapezium 1. Well, trapezium 1, it looked like this, just roughly. And if you look at the trapezium, I hope you can see that this trapezium is 1 unit across here, okay? So that's got length 1 there. It goes from 1 to 2. This height here, I think is 1. Yeah, you read across, you get to 1. So it's 1 high as well. And if you look at the other side, this side here is the other side, I think that's 4. It is 4, okay? Now, this trapezium, isn't it? It's been rotated, isn't it? It doesn't look like a starter. See, it's been rotated a bit. So when you label this, be careful. The parallel sides are here and here, A and B. I know it looks weird, but this is the height here, okay? The vertical height is just being turned around. So the area for this shape will be 1/2 A plus B times H, okay? The bracket's worth 5. Half of 5 is 2.5 times 1 is 2.5. That's the area of that shape there, okay? Area of shape 1. If we look at shape 2, it's another trapezium, a slightly taller one. There's something a slightly taller one, so I'll sketch it to that effect. Again, it's a slightly taller one. Okay, here, look. Again, I'm sure you agree. The height, again, is 1. It goes from 2 to 3. This height here is done already. It's already, we know that's going to be 4. Okay. The right-hand side, I think if you read the scale, you hit 5. Yeah, you hit 5 for the height there, okay? That's 5. And again, remember, watch with the labeling, because that's A, that's B, and that is H. So the area of shape 2 is 1/2 A plus B times H. And 4 add 5 is 9. Half of 9 is 4.5 times 1 is still 4.5. So 2 more shapes to do. You might spot a shortcut here with these, okay? Because trapezium 3 is basically the same as trapezium 2. It's just been flipped around. But I'll still do it the long way, okay? Trapezium 3 looks a bit like this. It's 1 long. That is 5. If you look back at the graph, and that's 4. So A, B, H. So the area of 3 is 1/2 A plus B times H. Well, again, that's 4.5. Okay, let me do that slightly better. 4.5, not 4-point squiggle. And then trapezium 4, I think, is a mirror image of trapezium 1. But again, I'm going to draw it out properly because, you know, it's good style and there's no rush here. So trapezium 4, again, it's 1 long, definitely. The height is 1. Again, it's 4, yep. And then 1 again, I think. Okay, so this is 4, that's 1. And again, just be careful, okay? This is H, that's A, and this here is B. I'm running out of room a bit here, sorry. So area 4 is 1/2 A plus B times H, which again is 2.5. And obviously to finish it off now, okay, I'll put it in green here. For the total area, you just have to add up all the separate areas. So you've got 2.5, add 4.5, add 2.5, plus 4.5. And if you add those up together, I think you get 14. Okay, you get 14. Remember though, it's an area. So what will the units be? Well, you don't know, isn't it? Because these marks on this graph, they're not in centimeters, right? They're not even in inches. They're just in some random unit. So all you know is it's going to be 14 units squared. Okay, sorry it's a bit messy, but the answer should look like this: 14 units squared. Okay, so you don't know what the units are. All right, and that's the trapezium rule there. Okay, all right, it is quite long. But once you get into the habit of drawing the ordinates up properly, drawing the shapes properly, all right, look for symmetrical trapeziums, and that will also save you time. So that's done. All right, thanks for listening and watching. Stay safe. See you soon. Nice one.